So, Marcus, one of the recent developments here in the Fibre Channel standard is this concept of fabric performance impact notification. So, can you maybe help me understand a little bit about what is FPIN and why would anybody care about it?
Fabric Performance Impact Notification is an addition to the Fibre Channel standard that defines how the fabric can notify the devices about an issue seen in the fabric. These are, for example, link integrity issues, lost frames, or congestion issues. And then the devices, which obviously the receiver will be the HBA, can then take a corrective action or forward that information up to, for example, the storage controller on a storage device or to the server layer, for example, the volume manager or the MPIO layer, depending on what kind of issue is seen in the fabric. The reason it's important is because there are certain situations that have an impact on performance in the fabric, such as link integrity issues or congestion, where the fabric can only do so much to mitigate the problem. But by alerting the devices can take a corrective action and either completely solve or mitigate the problem. So that's really the reason why FPIN is important.
So basically, it's an ecosystem, and if you use the ecosystem, you can solve the problem faster.
Yeah, so with Fabric Performance Impact Notification, really what you get is a new fabric service. And when the HBAs log into the fabric, they're notified that FPIN is available. And if the HBAs are available, which all newer HBAs are, they can subscribe to the service. And now you get a holistic approach to solving problems in the fabric, where the devices actively can go in and take an action if they're causing, for example, congestion, or if the device that they're communicating with is causing congestion, then the device can mitigate that. Or in the case of you having link integrity issues, they can basically forward that information up to the multipath layer, and the multipath layer can take a corrective action. So it's really an ecosystem collaboration solution here based on a new fabric service, which is Fabric Performance Impact Notification.
So Marcus, there's this new release of FC-NVMe-2, right? So non-volatile memory express. We've had NVMe over Fibre Channel fabric for a little while now, for a couple of years actually in play here. Can you tell us a little bit about what FC-NVMe-2 is and why is it important? What's going on there?
What's defined in FC-NVMe-2 is a concept called sequence level error recovery. And the whole idea here is to be able to create a recovery mechanism when devices are communicating with each other and a frame is lost for some reason. And the purpose is that the upper layer protocol, in this case here, NVMe or FC-NVMe, never really realized that there was a problem. And if you can have the recovery happening at a sequence level, then you don't hit the timeouts and the slow recovery that always happens at a protocol layer. And so what the FC-NVMe-2 standard defines is basically the standard for sequence level error recovery. So what happens when a sequence is in process and a frame is lost, there's basically a timeout value that's hit, and then the devices will query, hey, where are we with this exchange? And then there is a recovery mechanism to continue the exchange without, again, the upper layer protocol, FC-NVMe, ever realizing that there was a lost frame. And so the whole purpose is to ensure that applications perform a lot better and without any impact in case there is a lost frame.
So Marcus, if I take FC-NVMe-2 together with the FPIN, the Fabric Performance Impact Notification, this really looks like something that's going to allow us to solve the problems at such a low layer that the application's never going to know anything was going on. And obviously, that's a big benefit. But am I also right in thinking that that this is something that exists in Fibre Channel that doesn't exist in other technology?
Yeah, that's completely right. And I think the advantage you have with the Fibre Channel technology is that there's already a defined framework for Fabric services with respect to the FPIN capability, right? Fabric services is something that we've had in Fibre Channel since the beginning, and it's really just utilizing the same architecture or framework to be able to notify the devices. The other part, which obviously also plays in when we talk about FC-NVMe2, is the commitment from the ecosystem to create the best possible storage network. And those two hand in hand is really what creates this ability to be able to either completely correct or mitigate when problems occur at a layer below the storage protocol, and therefore with minimal or no impact at all to your application.
So Marcus, one of the things that keeps coming up as a question from customers is, okay, this NVMe over Fibre Channel Fabric stuff sounds pretty cool. I like what you guys are saying about the performance and where this is going to go. Now that I'm ready to try it, can somebody please tell me, what's the recipe look like? What are the building blocks? What do I need to do? How disruptive is this going to be? What do I change, right? Maybe you could walk me through that.
That is really the question that always comes up. And AJ, to start with, most customers already have the environment in place that supports NVMe over Fibre Channel. NVMe over Fibre Channel is supported on Gen 5 infrastructures and later, as long as the HBAs in the servers are Gen 6 or later. And the arrays, most vendors have arrays today that support NVMe over Fibre Channel as well. And so that means that you can run NVMe and SCSI concurrently on the same physical ports on the server, on the storage, and obviously across the fabric. And so that means that you can then transition stepwise. You don't have to do all or nothing, right? You can take one application at a time or one VM at a time. So for all the operating systems that we use in the enterprise today, there's now support for NVMe over Fibre Channel, often with built-in drivers in the latest, 2 versions of these operating systems. And with VMware supporting FC-NVMe when they came out with vSphere 7, you can now, on your ESX server, simply deploy or provision a data store backed by an NVMe namespace on the array. And then you can start moving your VMs over to that data store from a SCSI-backed data store without taking the application offline, simply using storage vMotion, which means you can do I would say, completely seamless transition from SCSI to NVMe on your VMware platform today.
So in a Fibre Channel SAN, if I understand you correctly, we can do a migration from the older SCSI technologies into a newer NVMe technologies without dropping the application in VMware, right? Just making this migration, getting better performance out of it, do the migration, and I don't rip and replace my switches for Ethernet switches, lossless Ethernet switches, or have to swap out something else. This is very, very straightforward then.
That's completely correct, and I think the beauty of it is that you don't really have to learn anything new either. You're using the same provisioning procedures or process as you use for provisioning with SCSI on your all-flash array. It's simply, it's just called a namespace instead of a LUN. You still use zoning in the fabric, and it's the same steps on your server when you mount the namespace instead of a LUN. So really, no learning curve. And as we just talked about in the VMware example, you can move your applications without taking them offline to NVMe from SCSI.
That seems like a pretty brilliant step to me.